Okay, this is section 3.2, page 8. We're going to look at how to find derivatives on the calculator. So we have this function we're interested in. We want to find the derivative at 9. A couple ways to do this. You could be on the home screen of your calculator, and I could just use my n-derive formula. Remember, that's math 8, and I need to put in the variable of interest there, put in my function there. You could also use y1 to enter your function and then refer to y1 from here. I'll show you that in a minute. But for now, I'm just going to enter the function itself there, and then move arrow right, and the x value we're interested in is 9. Hit enter, and it gives me 63. So basically, we'll jot down what we did here. Okay, and that answer was 63. Okay, so that's one way to do it automatically. We could also graph this function, and there's actually a couple ways that the graph can help us here as well. So from the graph, let's go to our y equals screen. I'm going to put in y1 is this function. Now I'm going to put in y2, the derivative of the function. So let's go on and do this. I've already put the function in here. And then for y2, we want to use the n-derive function, so math 8, and the same format that we just used, x there. Instead of entering the function again here, I'm going to just refer to y1. So in the new operating system, alpha F4, y1, and the x value I'm interested in is 9. And if I graph from there, let me quit that because that showed more than I wanted to show. So if I graph from there, I've already changed my window. Y equals about 500, I think it was. Here is the derivative. Y2 is being graphed right there. There's the derivative, and it's just a numeric value. If I move on to that graph, if I hit trace, you can toggle in between the graphs. So here's the first graph, y1, and I can arrow down, and I'm going to y2 equals n-derive, and you can see that no matter what the x values are, the derivative is right there, 63. Okay, I'm going to go ahead and fill this in like it was. And we can see also that it's equal to 63. So you could use trace to get that. I could also just go to table, and if I look at table, there's all my x values, my y values, and then you notice that y2 is always 63. Okay, so that's a couple ways to do that. If I wanted to write the equation of that tangent, of the tangent line at f prime and 9, not just to find out what the derivative value is, but I want the equation of that tangent line, I know I need two things, a slope and a point. So the slope is 63. I know that to be true. And the point is 9 something. A way to get that point, a couple ways I could do that. I just need y1 evaluated at x equals 9. So here's a way to do that with function notation. I'm going to go alpha F4, get y1, and then just like function notation, I'm going to plug in 9, and I get the value 255. So using the point slope version here, I got y minus 255 equals the slope of 63 times x minus 9. I want to see what the graph of this looks like, so I'm going to go ahead and put this in slope-intercept form. It's going to give me 63x And minus 9 times 63 plus 255 turns out to be minus 312. So this is my equation of the tangent line at x equals 9. Actually, I could get this also from the draw menu. So in the draw menu, I can do this from either the graph or from the main screen. So first from the main screen, I'll show you. Go to second draw. So second draw. And there's a few choices. I want tangent. So let's select 5. And it's asking tangent of what? So I'm going to put in, what you put in is your function. So you could type in the whole function, 4x squared, whatever it was, minus 9x plus 12, but we could also just use y1. So I'm going to do that, y1, and then comma, the point that I want the tangent line at, which in this case is 9. Hit enter, and it's thinking about it. And there's my tangent line. You see it just come in here. Now in this form, I can't really tell anything about that line except kind of what it looks like here. Depending on where you start this from, if you're from the main screen, this is what you're going to get. If you want to clear that line, by the way, you'd have to go to second draw, clear drawing, and then it'll just give you the functions back that you had. But actually from this screen here, after the graph is drawn, I'm going to do the same thing. I'm going to bring up the draw menu from here while I'm in the graph screen, and you get a little bit different results. So I'm going to go second draw, tangent again, 5, and then it doesn't give me this part to enter the graph because it already knows the graph. So it's on y1. I definitely want to be on y1, not on that derivative line. So I'm on y1. It's asking for the x value. I'm just going to type in 9. So I'm entering x equals 9. Hit enter, and it's thinking about it. There's the line. And now, if you take a look at what it shows you right away, it says at x equals 9, the tangent line is 63x minus 312. So that's the one place that you could get the equation of the line. Now this one works out nice because it's whole numbers. Sometimes if it's fractions or irrational number, it's going to include a lot of decimals in there. But it's still a pretty nice thing. Alright. You could actually graph the equation of the derivative without actually ever figuring out the equation. Because sometimes it's going to be more difficult to figure out the equation of the tangent line. So it is possible just to visually see the equation of the tangent line without having to graph it. So here's one that we can try with that. Let's quit that. And I'm going to go in. I'm going to do this in my y equals screen. So I'm going to clear these. So on y1, we'll do 1/3 x cubed. I'm going to go ahead and use my fraction here. 1/3 x cubed. And I'm going to use y2 for the derivative. Math 8. Variable is x. The function is y1. I've been using alpha F4. There is another way to get the function, and particularly if you have the older calculator where you don't have the function keys. You can go to variables, y variables, function, y1. A few extra steps, but it gets you there. And then for the x value, instead of picking a particular point, like we did on the last one, we picked 9, we're just going to say, give me all the x's. And so this is going to graph the entire thing. Okay, so I'm going to hit enter here. I'm going to do zoom 6 to get my last window reset. So there's the function. derivative is thinking about it. And there's the derivative. Now if you notice, there's it's hard to differentiate. It's hard to tell the difference between the function and its derivative. I'm going to go back to the screen, and I'm going to make the derivative a thicker graph. So I'm going to go to the left, hit enter, and that's going to be my thicker line. And now let's graph it again. There it is. So you can see exactly where the derivative is. I'd recommend this using that a different thickness, or use a dotted line or something for your second graph, especially if it's graphs that you're not as familiar with and it's harder to figure out which one is the graph itself and which one is the derivative. Anyway, the downside of this, you can't see the equation of that derivative, but you can use trace and make sure you're on the second graph. You can use trace to see particular values on that derivative, or better than that, you could use second table to look at particular values. So y2 was my derivative, and if I want to know the derivative of the function at x equals 1, it's 1, x equals 4, it's 16, and so forth. So I'm just going to note here, I filled in what y2 was, and I just want to note here that instead of putting in a particular value, we put in the x there. So we'll say fill in x instead of a value like a, to get a graph of the derivative function. And you can use trace, or better, you can use the table to find particular values. Second Calc would give you some particular values too. Second Calc value, say x equals 5. I got to be on the right graph though. So you can use that top line to make sure you're on one graph or the other. So that would be another way to do it. So use table or calc value to find particular values. Okay. Alright, one more thing. Your calculator is not perfect, and here's an example of a time where your calculator makes a mistake with this derivative. Let's find the derivative value at 0 for the absolute value of x. So if you think about it, we graphed the absolute value of x. You should already know that the derivative there is going to be a problem at x equals 0. Y prime of 0 does not exist, right? Because the slope of the tangent from the left is not equal to the slope of the tangent from the right. But let's try this on our calculator. So I'm going to put in math 8. So, and we can do this. I'll just do this one on the home screen. So we got d dx. We'll put in absolute value of x. I'll show you where that is if you don't know. And at x equals 0, and let's see what we come up with. Okay. So we have math 8. The variable is x. Absolute value, if you go to math number, it's the first choice there, absolute value. And it actually, the older calculators, it'll write ABS with parentheses. The new operating system actually uses absolute value symbols. So we just want the absolute value of x, and we want it evaluated at x equals 0. And your calculator says it's 0.